In this lesson, we're going to solve radical equations. That just means an equation that has a radical in it to begin with. The first thing you want to do is isolate the radical. So we want to get rid of the 3 off of the one side so that the radical will be all by itself over on this left side. Therefore, we end up with 5 now on the right side. We need to get rid of the radical sign, and the only way we can get rid of it is if we square, which undoes a square root. But if we square on one side, we've got a square on the other side. Therefore, the square and the square root kind of undo each other, and you end up with 2x minus 3 equals 5 squared, which is 25. If you continue the solving process like I did, it's just algebra to get to x equals 14 in a couple of steps. Now, it's very important that you check this answer. In the past, it was optional whether you check that or not, because if you did all the steps right, you were right. But when a problem starts out with a radical in it at the beginning, it's possible that this 14 won't actually work when you plug it back in for x, even though you did all the right steps to get there. And it's just the nature of squaring both sides. Sometimes you lose something in that process, like you could lose a negative, and so therefore it could cause issues with your answer. But 14 is the only possible answer, but if it doesn't work, you would just say no solution. But I'll save you some time on this one and tell you that it does actually work. When you plug it back in, you can try it. Our second example is also a radical equation. It doesn't look like a radical, but remember, if it has a fraction as an exponent, it is a radical in a sense. But we don't actually ever have to even change it into a radical. We can get rid of that 2/3 with a special trick that doesn't require us to change it to a radical. So the thing that's being raised to the 2/3 is the x plus 1. So that's the base. The 3 is not the base. It has nothing to do with the radical, so we want to get rid of it to isolate the radical on one side. 3 is being multiplied, so we divide by 3 on both sides. We end up with x plus 1 to the 2/3 equals 4. 12 divided by 3 is 4. So the trick to getting rid of the 2/3 is to do something that would cause the multiplication of 2/3 and something else to give you a power of 1. Because if we can get a power of 1, then we can just drop it off. And so what you do is you just take the whole side to the power that represents the reciprocal of the one that was already there. And so a 3/2 power is going to be the fix. So when you do 2/3 times 3/2, and the reason you can multiply those is because you have a base being raised to an exponent, being raised to another exponent, and that's when you're allowed to multiply the exponents. You get 6/6, which is 1. Well, if x plus 1 is being raised to the power of 1, we could just drop it off and not even write the power of 1 because it has no meaning anymore. And then on the other side we have, if you want to write it in a different form, it's the square root of 4 to the 3rd. So we'll take care of that in a minute. We've got one big issue that is going to be super easy to forget what to do with it. And it has to do with the whole idea that we talked about in another lesson, where if you have x squared, let's say, under a square root, well, if there is an even index and what you end up with is an odd power in the answer, then you have to put absolute values around your answer. Well, this is one of those situations because, remember, the index is the denominator, and we just took both sides and made them a square root, basically. And so because that is an even index, and we ended up with x plus 1 to the 1st power, then that's odd, so it causes absolute value bars to have to go on the x plus 1. So this makes it an absolute value equation now, which is going to end up giving us 2 answers potentially. So let's go from here. So what we have is the absolute value of x plus 1 equals 8, because over here, if you did that on the calculator or by hand, you would get a whole number 8. Now, when we have absolute value, you may remember that you split that into two separate equations. One equation is going to have no absolute value, and it's going to equal whatever's on the right side, which is 8. The other one is going to have no absolute value symbols, but you're going to write equals -8. And then you basically solve both of those separately, and you get two different answers. So if you take away 1 from both sides of each equation, you're going to get x equals 7 and x equals -9. Now, it is possible that one or both of those may not work, because as we talked about before, if you have a radical equation, an equation that has a radical in it to begin with, it's possible that one or both of your answers may not work. But once again, I did the check step already, and both of them check out. In both 7 and -9, if you plugged them in for the x at the very beginning of the equation and worked it out, you would get 12 both times. So our final answer is both 7 and -9, but you always want to check in this entire section that has to do with radical equations. You always want to check your answers, because you might find that one or both of them may not work. To review that absolute value rule and when you have to use it, again, it's when you have an even index, a variable that's underneath the radical. Doesn't matter if it's a regular number under the radical, you don't have to worry about this. It's when there's a variable under the radical, because we don't know whether that variable is a positive or a negative number, so we have to treat it a little differently than if it was just a number under there. And then when the answer turns out to be an odd exponent on that variable, that's when you need absolute value. Has to be an even index at the beginning and an odd exponent at the end. That's the only case where you need an absolute value around your variable and your exponent. So let's see what happens with this example. Again, you've got to isolate your radical before you get started with the solving process. So we're going to add 5 to both sides. Now that the radical is isolated, we can get rid of the square root by squaring, which undoes the square root. But when we square the other side, be careful to put parentheses around it, because you're squaring the whole x plus 5. After squaring both sides, the square undoes the square root, and you end up with an x plus 7. On the other side, though, that's squaring a binomial, which requires you to write it out twice and FOIL it, first outside, inside, last, and then it turns out that the two middle terms don't cancel one another out, but they combine to give you a 10x. So this is what we have so far. Now, when you see an x squared in an equation, you should get in the habit of remembering that everything needs to move to one side so that you can have a 0 on the other side. This is a quadratic equation, and the only form you have to work with is to move everything on one side and get a 0 on the other side. So I'm going to move the x and the 7 over to the other side, or get them off of this side, so we have a 0 on the left. After getting rid of the x and the 7 from the left side, we have 0 on the left side, and the other side combines to give you x squared plus 9x plus 18. One method of solving a quadratic equation is to factor it, and this one happens to factor, which is great. We get x plus 6 times x plus 3 equaling 0, and by the zero product property, we're allowed to say that either x plus 6 is going to have to be a 0 or x plus 3 is going to have to be a 0 if you get something times something equaling a 0. One of those two factors is going to have to be 0. In solving those, we get x equals -6 or x equals -3. But we have to check, because all the way at the beginning of the problem it was a radical equation. If you go back to the original equation, I'm taking each answer and plugging it in where I saw an x in the original equation. Looks like the -6 did not equal out on both sides, but the negative 3 ended up equaling out on both sides. So we're going to have to scratch the answer of negative 6, and our only answer is negative 3.